called the investigation of refrigerant system superheat. Let's first look at the classics refrigeration cycle. It comprises of 4 processes which take place in the compressor, condenser, expansion valve, and evaporator. And in this experiment, we are going to investigate the influence of superheat, which is the superheat degree that the refrigerant enters the compressor. And so it shows in the figure that it represents it as the length of this smaller line on this figure. So let's move on to the whole setup of our experiment platform. And in this experiment platform, all 4 components are here. This is the compressor, and the refrigerant enters the compressor and then moves to the condenser. The condenser has the pressurized and hot air is cooled down by the water flows into the condenser, and after condensed, it then goes out to the expansion valve, and which the high pressure refrigerant will become low pressure refrigerant and then enters the evaporator. And besides the 4 major components, we have measurement system here, and basically we want to measure the pressure and temperature. The pressure is evaporation pressure is measured by this pressure gauge, and the condenser pressure is measured by this pressure gauge. And besides, since we are going to investigate the degree of superheat, which means that the heat input into the evaporator should be controlled, so that this is controlled by evaporator input control system, and generally the product of the voltage and the current indicates that how many heat is input into the evaporator. And for the temperature measurement system, we have a lot of temperature measuring points, and we can look at the figure here. Like, this is a simplified figure made according to this experiment platform, and we have 7 temperature measuring points, which is the temperature enters the compressor, temperature out the compressor, and the temperature in the condenser and enters the expansion valve and leave the evaporator, and also enters the evaporator. So there are totally seven temperature measuring points. And so now let's begin this experiment. First, before open, so before opens this system, we should first increase the water flows, increase the water supply for the condenser, so that we can ensure that after the whole system works, and the hot refrigerant will be cooled down by the condenser, and then we can turn on the switch. So generally it will take several minutes to let it go into stable working condition, so that you will see the temperature of this temperature on display. This is changing with time because it hasn't reached the stable condition. And if you switch this, and if you turn on the switch, and you will find out the temperature at each temperature measuring point. So let's first wait for a second to let it obtain a stable condition. And because there are only one thing that needs to be investigated, that is the superheat, degree of superheat. So during the whole experiment, we're going to maintain the other parameters at the constant value, like the condenser pressure, because the evaporation pressure is correlated with the degree of superheat. So that when superheat change, this change, so that we need to maintain it this constant value. So how do we do that? We can control the condenser pressure by adjusting the flow rate that flows into the condenser, since the flow rate will influence the temperature here, and the temperature and pressure are actually dependent variables, so that we can simply reduce the flow rate to increase the pressure here, and we can see that the pressure is gradually increased. So at first, the first working condition is when the heat input rate to the evaporator is about 200 volts, and then later on we increase it with 200 volts in each step. So 200 volt is actually the product of the voltage and current. So we can see that now the current is about alright, now the voltage is around 90, while the current is slightly higher than 2 amp. So that the input power is around 200 volts. And I think we'll have to wait for another second for the condenser pressure to reach 800, since the 800 is the given point at this experiment. So, okay, let's wait, just wait. So now the condenser pressure has maintained at 800. So therefore it means that all of the pressure, temperature remain unchanged, and the whole system is under stable working conditions. So now we have to record the temperature at each point by switching this turn this switch. Now it is the temperature at the first point, and now it is minus 13.3 degrees Celsius, and then we switch it to 0.2, and it takes 4 seconds, and you can read the temperature of 0.2, which is the refrigerant temperature coming out from the compressor. That is 36.9 degrees Celsius, and then the temperature at 0.3, 0.4, and so in each step of the experiment, we have to record these 7 temperatures and mark it out. Pick up some useful temperature and mark it on the diagram on the. So after the first set of experiments, we then increase the heat input to around 400 volts, and therefore I think it's around here. The voltage is close to 150, while the current is slightly, the voltage is, I think around here, when the voltage is close to 150, while the current is more than 3, and so the total heat input rate is 400 volts. So we wait for another second, but before that, we have to make sure that the condenser pressure is still maintained at 800. So after it reached 800 and work at stable condition, we then record those 7 temperatures. So after we complete this process and we adjust, and I think after finish it, and then we adjust the heat input rate to 600 and then 800. So therefore the degree of superheat is measured 4 times, and you have 4 groups of data. And so for the repetition work, I will not elaborate here, and after this video I will give you the results of my measuring data. So I think that's all of these experiments. Thanks. Okay, sorry guys, that's not the end of this experiment. And if we complete the whole experiment, we should shut down these testing platform. So The first thing is to reduce the heat input rate into 0 and set the cooling water at its maximum flow rate so as to cool the whole system down. And then we keep it running for about 1 minute before we totally shut it down. And I assume that 1 minute has passed, so that now we can switch off the system. And then we turn off the cooling water thereafter. And remember to also close the electricity